So we want to discuss in this video how to solve system equations by elimination, or what is sometimes known as the addition or subtraction method. All right, so it's kind of a old school way. It was called adding and subtracting. Now it's called elimination, or you may have always called it elimination, but essentially what we're trying to do, and the reason it's called elimination or addition and subtraction, is the operation we're going to use is adding or subtracting. We're going to actually add the two equations together, or we're going to subtract the two equations. Okay, so that's where the addition and subtraction piece comes from. It's called elimination because in adding or subtracting, what you end up doing is you end up eliminating one of the variables. All right, meaning that they either subtract or add to give you 0. Okay, so we're going to go through the steps. We're going to do a few practice questions to show you how this works, and then we'll let you try some on your own. So the first thing you're going to do when you're trying to do elimination is you need to line up the coefficients in the variables. What that means is if you're looking at a question, okay, so we'll just look at this one. You want to make sure your x's are lined up and your y's are lined up, and then your answers are lined up. Okay, meaning they're sort of in a column. They're right on top of each other. So that's the first thing you want to do. If they're not lined up, line them up. In this example, they already are. Then you want to multiply if required. What that means is you want to make sure that one of the two variables, and it doesn't matter which one, has the exact same number in front of it. It doesn't have to be positive, or like they don't have to both be positive or both be negative. The sign's not important, but the value is. So if I look at this example, I notice that the x's are already lined up and they have the same number in front of them. So I don't need to multiply. If I wanted to look at y, though, you notice this is 4 and that's 2. So I could multiply this whole equation by 2. That's what I mean by multiply. So you're going to have to decide, am I going to get rid of the x's or the y's? And then once you've made that decision, if you're going to get rid of the x's here, you don't have to multiply because they already have the same number in front of them. If you're going to get rid of the y, you would have to multiply by 2. Okay, so that's what we mean by multiply. Then I'm going to not multiply because I'm going to use the x's. Then the next part is to add or subtract. So you make that decision based on the sign. So remember I told you the sign wasn't important in terms of the number, but now the sign is important because I want these x's to go away. So I'm going to have to subtract. Okay? So x minus x gives me no x's. They're gone. Minus 4y minus 2. You have to be careful here. It's minus 4 then plus 2. So I get minus 2y. And that equals, and then 1 minus 1 gives me 1 plus 1, which is 2. So I add them together or subtract them so that the variable that you're trying to get rid of is eliminated. That's why it's called elimination. And in this case, the x's are eliminated. Then we solve. Okay? So now we go back and we say, well, if minus 2y is equal to 2, then we just divide by minus 2, and y becomes minus 1. Right? So I solve. Then I replace that solve value into an equation to find the other value. So just like in the other two methods we were graphing, if you look at that video, or we were using substitution, once we have x or y, we need the other variable. So we're going to go back, and it doesn't matter, it makes no difference which one you plug into. So I'm just going to go x minus 4 times minus 1 is equal to 1. So that means that x plus 4 is equal to 1. So that means x is 1 minus 4. So x is minus 3. Okay, so all I did was plug into this equation. All right, I just pulled it out. You could have done the exact same thing, but with the other equation. So just to show you this, you don't have to do both, but just to show you, I could have went like this. Okay, plugged in y as minus 1 here, and that would give me x plus 2 is equal to minus 1. So then x is minus 1 minus 2, and x is minus 3. So I would get the same value either way. All right, so it doesn't matter which one you plug back into. Once you've got the value of y, you can get the value of x from either one. And then the last part is always to just verify your solution. Okay, so we can always check our answer. So let's do that with a different color. We'll do it in green. I'm going to check the first equation first. So I'm going to go x is minus 3 minus 4 times y is minus 1. and that's going to equal 1. So I get minus 3 plus 4 equals 1. Okay, because minus 4 times minus 1 is positive 4. So that gives me 1 equals 1. And I say, yes, that is correct, because 4 minus 3 is 1. The second equation is this, x minus 2y equals minus 1. So x is minus 3 minus 2 times y is minus 1. And that's supposed to equal minus 1. So I have minus 3 plus 2 equals minus 1. And that makes it minus 1 equals minus 1. And I say, yes, that's also correct. So I know I'm right. So my solution, again, you can write it as a coordinate pair. So my solution is minus 3 and minus 1, and I know that it works. And that's the beauty of solving equations, because you can always know that it works because you can check it. And that's not always true in math, but a lot of times it is, and it always is if you're solving an equation. You can always go back to the original and plug in the solution and see if it works. So let's try another example. So if I look at this example, the first step is to try to line everything up. So the x's are supposed to be lined up, and they are. The y's are lined up, and the answers are lined up. Then I have to decide, do I need to multiply? And that is going to be based on what do I want to get rid of. So here, I can multiply this equation by 3, okay? And that will give me 9x minus 12y equals 30. Okay, I multiply the entire equation by 3. And then the second equation I'm just going to leave alone. And that's going to line up my y values. Now you can line up your x values instead. If you did that, you would have to multiply this equation by 5 and this equation by 3. It would require 2 multiplications. Okay, once you've done that, then you decide, okay, I decided I had to multiply to get my y values the same. Now they are. So now I decide, am I going to add or subtract? And because the sign is the same, we're going to subtract. Okay, so we're going to go 9x minus 5x. That gives me 4x. The minus 12 minus minus 12, gone. And then 30 minus 6 is 24. So that means that x is equal to 6 if I just divide both of those by 4. Okay, so I get my answer for x. Then I go back, and again, you can plug into either equation. It makes no difference. I'm going to plug into this equation. So I'm going to go 5 times 6 minus 12y is equal to 6. So that means that 30 minus 12y is equal to 6. So that means minus 12y is equal to 6 minus 30. I just bring this 30 over. So minus 12y is equal to then minus 24. 6 minus 30. And that means y, if you divide by minus 12, is 2. So I get a solution. And then I have to check the solution. So I go back to my original, 3x, so 3 times 6 minus 4 times y, which is 2, is supposed to equal 10. So that gives me 18 minus 8 is equal to 10. And I say, yes, 10 then equals 10. So that works. Then I do the other equation. So 5 minus x is 6. Or sorry, 5 times x, which is 6, minus 12 times y, which is 2, is equal to 6. So that gives me 30 minus 24 is equal to 6. And I get 6 equals 6. So, yep, that also works. So then I know my solution, which is 6 and 2. I know that that is the correct solution. Okay, so that's the idea of elimination. If you look at this one, we'll do one more example. It really makes no difference here. I'm going to multiply this and this because those numbers, 2 and 3, the greatest, not the greatest, but the least common multiple, I guess, is 6. We have to get the 6 for each of them. So I'm going to multiply this by 3 or 2 and this by 3 or 2, depending on whether you're going to do the x or the y. I'm going to line up my x's. Actually, sorry, I'm going to line up my y's here. So let's multiply this by 3 and this by 2. Okay, so if we do that, we get 9x minus 6y is equal to 15. And we get 4x plus 6y is equal to 24. Okay, and here, the reason I did that is just to show you here we're going to add. which is different than the previous two examples. We're going to add because it's the y values that we lined up, and they're both 6, but one is negative and one is positive. So because the signs are opposites, when we add them, they're going to go away. So 9x plus 4x, that's 13x. Minus 6 plus 6, that's what I mean. Now that's 0. And then 15 plus 24 is 39. So if I divide by 13, x becomes 3. Okay? Then I go back to either equation, doesn't make any difference. I'll do the first one. So 3 times 3 minus 2y is equal to 5. So 9 minus 2y is equal to 5, which means minus 2y is equal to 5 minus 9, which means minus 2y is equal to minus 4, which means that y is equal to 2. Okay, so I get my answer. And then again, you have to check. Is that actually right? So I go 3 times x, which is 3, minus 2 times y, which is 2, is supposed to equal 5. That's the first equation. 9 minus 4 then equals 5. 5 is equal to 5. We say, yep, that's right. Then we do the second equation. So 2 times 3 plus 3 times 2 is supposed to equal 12. We get 6 plus 6 is equal to 12, and that is correct. 12 does equal 12, so that is right as well. So I know my answer, which is 3 and 2, is the correct answer. So that's the method of elimination or addition and subtraction. You'll hear it called both. And again, here's some questions for you to try, and we'll leave it at that.